Okay, as they sang in Janessa and Donovan's favorite Disney movie about a princess, Mulan, let's get down to business. That was a pretty good joke, I thought. Okay, so anyhow, we're going to be going over spheres today. This is your assignment where you had to be finding the volume of various spheres in this situation. So what we're going to be doing is, so the first thing that we want to do is that there are parts of a sphere that you need to know. Okay, so this part right here, so right there, that is called the center point. Okay, so the center point is the exact, what would be the center of the sphere. Now remember, like we talked about in class, that center point is actually floating in space. It's right in the very, very, very center of the sphere, but it's floating in space, so it's not touching the sphere. Okay, if you have a line segment that goes from the center point through the sphere to a point on the sphere, that would be what is known as a radius. So spheres have radius. If you have a line segment that goes through the center of the sphere where both of the endpoints of that line segment are on the sphere, that is what is known as a diameter, and that would make sense because if something has a radius, it's also going to have a diameter. Okay, and then this part right here, which is kind of like if you think of a sphere as a globe, this part right here, which would be the equator, okay, you guys, this is called the great circle. All right, so this part right here, which I'm shading in, that is what is known as the great circle. Okay, the great circle, and the reason why we call it the great circle is because if you slice the sphere anywhere, that circle right there that goes right through the middle of the sphere, that would be the largest circle you could possibly create. Okay, so we're going to be finding the volume of each one of these spheres. And notice, then going back up here for a second, notice that it says the great circle slices the sphere into two hemispheres. So you need to be aware of what that term is. Hemisphere means half of a sphere. Okay, so going down here, numbers 1 and 2, notice we're missing 3 and 4, 5 and 6. We're going to be finding the volume of each one of these spheres. Okay, so what's the formula for volume of a sphere as it was taught in class? You take the number 4, you multiply it by the number pi, you multiply it by the radius cubed, or radius to the third power, and then you divide by 3. So what that's telling us is that the radius is the only unknown that you don't know that you have to know in order to find the volume of a sphere. So if you notice in number 1, we've got this line segment here going from the center point of the sphere to a point on the sphere, so that is the radius. Okay, so in the place of the radius, we're going to substitute the value of 7. So that means I'm going to take 4, I'm going to multiply it by the number pi, I'm going to multiply it by 7 cubed, or 7 to the third power, and then I'm going to divide by 3. Okay, so once I do that, you guys, once I know the radius, I just write it down, and then I just go to my calculator and I let my calculator do all the mathematical computations for me in order to find the volume here. Okay, so, and when I type this into my calculator, I actually use the parentheses. So I would go 4, and then I would multiply it by pi, and I'm just going to use the pi symbol in this case. If you don't want to use the pi symbol, and if you want to use, you can't even see that because of the glare on the screen. Let's see if we can get this so you can see it. There we go. If you want to use the 3.14, the approximate value for pi, you can do that. Okay, that is not a problem. And then I'm going to multiply this by 7 to the third power. And like we talked about in class, you have to know how to program, how to talk to your calculator in order to do a third power. All right, and then when I do this, I work out the entire numerator. I press equals, and it's telling me that I made an error somewhere. I'm not too sure where I made the error, so let's put this. Okay, 7 to the, oh, I see what I did. That's wrong. Sorry, I got to fix this for 1 second. I'm going to change that into a parentheses, and then I'm going to have 7 to the third power. Sorry, technical difficulties. I see what that equals, and then I have to divide it all by 3. So my volume, my numerical value for my volume is 1,436 point, and then remember, if you get a decimal, and you will get a decimal with these particular problems, and the reason is because we're dealing with pi, round it to the 10th. So 7 is in the 10th spot, but the 5 would make that 0.8. So 1,436.8. Put the measurements down, which in this case is inches, and volume is always to the third power for the measurement. So 1,436.8 cubic inches is my volume for number 1. Okay, number 2, I'm going to find the volume of this sphere. So once again, the first thing that I like to do is I like to write down the formula. So to find the volume of a sphere is we take the number 4, we multiply it by the number pi, we multiply it by the radius cubed, and then we divide by 3. So like we just talked about just in the previous problem, the only unknown value that you need to know is the radius. So I look over here and I say, okay, well, is this line segment right here a radius? No, it's a diameter, so the diameter is 34, but if the diameter is 34, that means the radius has to be half of that. Okay, so the radius is going to be 17. 17 and 17 make 34. So I'm going to substitute that 17 into the place of the radius into my formula. And when I do that, I get 4 times the number pi times 17 to the third power. That's going to be a pretty big value. And then I'm going to divide by 3. Okay, so once again, once you get to this point, all it is a matter of correctly typing it into your calculator. Alright, so I just take the number 4. See if you can see that. Yep, so I can take the number 4. I multiply it by the pi value, and I'm going to use the pi symbol, and then I multiply it by 17 to the third power. Okay, and I could actually do third power right here if I wanted to on this particular calculator. Okay, that equals 61,738 and a bunch of decimals, some change as we say in the math world, and then I divide by 3. Alright, so there's my volume, 20,579 point, and then I'm going to put the very first number after the decimal, so the number that's in the tenths place value, which is 5. Alright, put the measurements down, centimeters, and make the measurements cubed. So there's the volume for number 2, 20,579.5 cubic centimeters. Okay, so in number 5 and number 6, notice the instructions say, find the volume of each hemisphere below. Okay, so what is a hemisphere? Once again, a hemisphere is going to be half of a sphere. Okay, so here's what I have to think about. Just you've got to contemplate this. So the volume formula for a sphere is 4 times pi times the radius cubed divided by 3. But if I'm only finding that formula is for an entire sphere, but I'm only finding half of a sphere, so what do I have to do? Well, I have to divide this formula by 2. Okay, now, so that would be the formula that I use to find the volume of a hemisphere. Okay, now if I'm dividing by 2, really what that means is that I'm taking this 3 and I'm multiplying it by 2. So one way that you can think of a hemisphere, you can think of it as 4 times pi times the radius cubed, and then you could divide by 6. Okay, why is that? Well, because if you divide by 3, but then you divide by 2, 3 times 2 is 6, really that means you're dividing by 6. Okay, I hope that makes sense. So, but the only value, so I'm going to use this formula right here for a hemisphere, okay, which is the same thing as this formula over here. If you're uncomfortable with this formula, use that one, it's okay. So the only value that I need is the radius. Go over here, the radius is clearly marked as 5. So that means my volume is going to be 4 times pi times 5 to the third power. 5 once again is my radius, and then I'm going to divide all of that by 6. Where did the 6 come from? I explained it earlier. It was the 3 times the 2. Okay, typing this into my calculator, once again, once I get to this point, all I need is a calculator. You don't want to work this out on paper, or you want to avoid working it out on paper. So you take the number 4, you multiply it by the value pi, or the number pi. We're going to multiply that by 5 to the third power. And I'm going to see what that equals, and then I'm going to divide it all by 3. Okay. The reason why I see what the whole numerator value equals before I divide by 3 is I've just learned over the years, and hopefully you caught the mistake I made. I'm going to divide by 6, but I've just learned over the years that depending on which calculator you're using, It's just safer to see what the whole numerator value equals and then divide it out. Okay, so there is my volume of my hemisphere. So my answer is going to be 261 point, and then I'm going to write the number in the 10th place, which is a 7, but because the 7 has a 9 next to it, that's going to make it 0.8. It's going to round it up. Okay, kilometers cubed. 261.8 cubic kilometers is going to be my volume of number 5. Number 6, once again, I have a hemisphere, so I'm going to use the formula that I just explained in the previous problem to find the volume of this hemisphere. So I'm going to take the number 4, I'm going to multiply it by the number pi, I'm going to multiply that by the radius cubed, and then I'm going to divide by 6. Alright, so what's the radius? Well, you can see from the diagram this line segment, because one endpoint is on the sphere and the other endpoint is on the sphere, and because it goes right through the center point of the hemisphere there, that's going to be a diameter. So my diameter is 18, which means that my radius is going to be 9. A radius is always half of a diameter. So substituting 9 into my formula for the volume of a hemisphere, it becomes 4 times pi times 9 to the 3rd power, all divided by 6. Okay, and once I get to this point, I just plug it into my calculator over here. Okay, I'm trying to find a sweet spot so you could see my calculator on the screen. That looks okay, so I'm going to take number 4, I'm going to multiply it by the number pi, I'm going to multiply it by 9 to the 3rd power. And you got to know how to do 3rd power on a calculator, or it's, now like I said in class, remember, if you don't know how to do 9 to the 3rd power, well, you could just simply type in 9 times 9 times 9. That's the same thing as 9 to the 3rd power. Alright, so I see what that equals, and then I'm going to divide it all by 6. So 1,526.8 is my volume here. So I get 1,526.8. Put the measurements down, which are feet, and then cubed. So there is my volume for number 6. Okay, turning it over to the back side, I have one problem to do on the back, and this is what it says. It says the Henleys. Ooh, Henleys. Maybe that's Don Henley, one of the lead singers of the rock and roll band the Eagles. Okay, but anyhow, who cares who it is? But they have a silo on their farm to store grain. All right, assuming the entire space is used, what is the maximum amount of grain that the silo can hold? Okay, so we're trying to figure out how much grain can this silo hold. All right, so we want to fill this silo up with grain. If you've ever been to the Midwest, you've seen these silos. They fill them up with grain or missiles, one of the two. Okay, so anyhow, so we want to find the volume. All right, well, here's the problem. So really what this problem is saying is it wants to know what is the volume of this shape right here. Well, here's the problem with this shape. It's not any shape that I recognize. It's a combination of two shapes, okay? So really what we have here is that we have a hemisphere, which is the top of the shape, and this is what the hemisphere looks like. All right, where the diameter of the hemisphere is clearly marked as 22 feet. I'm just going to put 22. I'm not going to put the feet. Plus, we have the shape below the hemisphere, which is obviously a cylinder. Okay, so we have this cylinder that the hemisphere is on top of. So really, what we have to do is we have to find the volume of the hemisphere. Then we have to find the volume of the cylinder, and then we add the two of them up. Okay, so the cylinder, as you can see, the top of the cylinder is the same as the bottom of the hemisphere, so which is marked with a diameter of 22. So that's 22. But what's a little bit tricky is you have to figure out the height of the cylinder. So if I go over here to my diagram, the cylinder's height is from that point to that point. So from there to there. And that's not 45. 45 is the entire height of the entire silo. Okay, so we need to figure out, first of all, I think, just what's the height of the cylinder. Okay, so how are we going to do that? Well, here's what we're going to do. We're going to go to the center point of my hemisphere, and I'm going to draw a line just going straight up. Now, if you see it, notice that's the radius of the hemisphere. It's right here. So that's the radius. Well, the diameter is 22, so that means the radius is 11. So that means that point right there is 11. Okay, well, if that entire line, if the entire height is 45, and that's 11, that means that this part has to be 34. 34 plus 11, or 11 minus 45 is 34. So that means my height of my cylinder is 34. Okay, so now I have to recall the formulas. All right, so what's the formula for volume of a hemisphere? Well, you should remember that. We just did it in the previous problems. It's 4 times pi times the radius cubed, and then we're going to divide it all by 6. We divide by 6 in a hemisphere. Okay? Then we're going to add that to the volume of the cylinder. So what's the volume of the cylinder? Well, you need to remember that, but I'll help you out if you don't. It's pi times the radius squared times the height of the cylinder. Okay, so let's go ahead and plug in what we know. So in this formula, I need to know the radius. What's the radius? Well, we just determined it. It's 11. So to find the volume of the hemisphere, I'm going to go 4 times pi, and then I'm going to multiply that by 11 to the third power, or 11 cubed, and then I'm going to divide that all by 6. Plus, then I'm going to find the volume of the cylinder, which is pi times the radius. Well, the radius is the same as the hemisphere, which is 11, but it's 11 squared, for it's squared in the formula for volume of a cylinder, times the height of the cylinder, which we said was 34. Okay, so once we get to this point, now this is just a matter of, hey, use my calculator. Hey, look at that, I found a sweet spot. So you can see my calculator as I work it out. So I'm going to find the volume of the hemisphere first. So to do that, I'm going to type in 4. I'm going to multiply that by pi. I'm going to multiply that by 11 to the third power. Okay, I'm going to see what that equals. Just safer that way. Then I'm going to divide by 6. I'm going to write that value down, 2787.6. So 2787.6. That's the volume for my hemisphere. Then I'm going to see what's the volume of my cylinder. So for my cylinder, I'm going to go pi times 11 squared. Multiply that by 34, which is the height of the cylinder. I don't have to divide by anything because there's no dividing for volume of a cylinder. And that is 12,924.5. So we get 12,924.5. So then to find the total volume, and which would be how much grain this silo can hold here, I would just add those two values up. All right, so I'm going to clear this out, and I'm going to go 2787.6. I'm going to add that to 12,924.5. And there's my total volume. So that's how much grain this can hold, 15,712.1. All right, so 15,712.1, and then it's cubic feet. Okay, so that's how much grain this silo can hold. And there we go. Okay, so signed, sealed, and delivered. Peter Frampton sang that song. Look it up on YouTube, old school.